Hello, welcome to our class. This is Psych 1, and this week is week 8. And in this week, we are going to talk about the stuff in chapter 7 on the textbook. So last week, we have talked about learning. So we have talked about different kinds of conditioning and talk about how people and animals can learn from experience. And this week we're still going to talk about some stuff in cognitive psychology. So we have in this class we have talked about the history of psychology in the first lecture. We have talked about biopsychology in chapter 3. We have talked about some other stuff like consciousness, perception, and sensation. And this week we are continue talking about some topics such as cognition itself, language, problem solving, and intelligence. So let's start the lecture. So before the lecture, here is a very interesting question or small test for you to think about. So for example, if imagine you are living in the New York City, and you can see a picture, a map on the right side. Here's it's a map of Manhattan. Manhattan is a part of the New York City. It's an island of New York City. So there's one night you're in the Upper East Side of Manhattan. So you're in this area, Upper East Side of Manhattan. And the question is, how do you get to the Upper West Side? So Upper West Side is here. So here is the start, here is the end. So which route would you choose to start from the Upper East Side and reach at the Upper West Side of Manhattan? What kind of route would you choose? So you can see that between the two places, there is the Central Park here. So this area is a park. It's called Central Park. It's a very huge park in the New York City. So on the right side is Upper East Side, and on the left side it's Upper West Side. You are in the Upper East Side right now in the night, and your home is Upper West Side. Which route would you choose if you walk? If you walk from Upper East to the Upper West, what kind of route would you choose? So you can pause the video right now and think about it. Okay, so probably you might choose to just go through the Central Park from Upper East Side to the Upper West Side. So you just go through the Central Park because it's a park and there are some kind of roads in the park. However, the people who are living in New York City a few times told me that it was a wrong decision if you walk in the Central Park in the night, because Central Park is very famous for its danger in the night. Because in the night it's very dangerous in the night. It's daytime. If you go to the Central Park to walk or running, it's okay, but in the night, nobody goes there except the dangerous people. So there are a lot of bad people there who want to commit crimes, and there are some other kinds of people who are very dangerous. So if you walk inside of the Central Park in the night, it's not a good choice. So usually the local people in New York City will choose to avoid going into the Central Park. So the right way to answer this question is that you can go to the Middletown East first, and then you go to the Middletown West, and you go back to the Upper West Side of Manhattan. So you can see the route here. It's not a direct route. It's not really direct. It's a curved route, but it make you safe. It's a right way to do it. Or you can go to north first. You can go to East Harlem, and you go to the Harlem, and go to this place, and go back to the Upper West Side. So either way is okay, but do not go inside of the Central Park in the night. So sometimes this test may show that sometimes the direct way, it may not be a doable way. It's not workable. It cannot be worked. But sometimes you need to find another route that is longer, but it is working. And here is another test. So imagine that you have a coin. You want to toss the coin for a few times. And there, in the following, there are 2 coin tosses series. Which one is more likely to happen in reality? So there is a coin, and you toss it for 8 times. And which series is more likely to happen in reality? So H stands for head, and T stands for tail. So the first series is head, head, tail, head, tail, tail, head, tail. So that's the first series. So I toss the coin for 8 times. Here's the series. And the second series is head, tail, head, tail, head, tail, head, tail. So which one is more likely to happen in reality? So you can pause the video and think about it. So some people may say the first one is more likely. Some people may say the second one is more likely. And I would say that actually the 2 series are equal likely to happen. They're equal likely to happen. No one is more likely to happen. But from intuition, if we answer this question only relying on our intuition or our just a direct feeling, I would think that the first series is more likely to happen. Why is that? Because it looks like random. Because we know that if we toss a coin, it's random. It's usually random. So no matter you get a head or you get a tail, it's random. And every time it randomly happens, you can get each head for just random. You can get a tail randomly. And the first series looks like more random. It looks like really random. It's HHT, HTT, HT. It looks like really random. But the second one, it doesn't look like that random. It's so non-random. It's like a HT, 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 HT. So I would think that why T always follows H and H always follows T. It is not reasonable. It doesn't make sense, right? So it's not really random. It doesn't look like random. However, through reasoning, through some kind of mathematical reasoning, if you learn probability, you will know that these 2 series are equal likely to happen. Because every time you toss the coin, you get half of the chance to get H and half of the chance to get the tail, right? So no matter you get H or T, it's half of time. So every time is half of time to get either one. And you toss it for 8 times. So every time you toss it, and the first time has nothing to do with the second time. The second time has nothing to do with the third time. Every time you toss the coin, it is independent. It means that these 8 events do not have any relationships. It means that every time you get a half chance to get H, half chance to get the T. So every series, the chance to get either of these series, you can calculate the probability to get either of the series. So how to calculate it? It's like 0.5 times 0.5 times 0.5 times 0.5. So why it's 0.5? Because you get half of the chance to get either H or T. So no matter you get H or T, it's a half of time. And the next time you get either H or T, it's also 0.5. The probability is 0.5. And you need to multiply that 2 chances. So that's the final result if you toss for twice only. But you toss it for 8 times. So you time the 0.5 for 8 times. So it's 0.5 times 0.5. So it's actually 0.5 to the 8th power. The nature of it is like that. It's like, here is 1, 2, 3, 4, 5, 6, yeah. Yeah, so the formula to calculate the probability for each series is like this. It's like 0.5 to the 8th power, because you get half the chance to get a result every time. And there are 8 times. The way to calculate the probability for these 2 series is totally identical. It's the same. It's the same way to calculate the probability for the 2 series. So there's no difference. They're equal likely to happen. Even though the second series looks like not random, but it's actually random. So yeah, it is a second test. And sometimes it's from our intuition, from our feeling. The answer is yes, but in reality, the answer is a different one. So let's start the lecture. Let's talk about cognition. So we have talked about cognition for like 2 or 3 times already. Like we have talked about sensation, perception. We have talked about consciousness. We have talked about learning. But what is cognition? What is cognitive psychology? So cognition is actually thinking. It's all the conscious activities in our brain. It's a combination, it's a collection of all the conscious activities in our brain. That is cognition or thinking. So cognition or cognitive basically means thinking. And there are different components of cognition, because in thinking we do a lot of things in our brain. There are a lot of stuff going on in the brain when it is working. So there is perception. So we have talked about perception. So it transfers the sensory information into the information that we know in the brain. So here's a perception, and also there is knowledge. So knowledge, we know some knowledge. some useful information that we can remember, so that every time we need to use some kind of knowledge, we can use it. Here's a problem solving, because we might meet a lot of problems in real life. We need to solve those problems. We have strategies to solve problems. So we need to involve in some conscious brain activity to solve that problem. And also here's a judgment. We need to judge, we need to make decisions, we need to judge whether it's good or bad, whether which road to go, and which one to choose, something like that. And also there's language. We can speak, we can understand other people's language. And also we have memory. We can remember things. We can remember the knowledge. We can remember what was going on before. And there might be some other parts in the cognition, but cognition is just basically the thinking process. And cognition is the essential feature of consciousness. So how do we know we have consciousness? We can say that we have the ability to think. We can think. We have, our thinking is going on all the time when we are awake. So thinking is the most important feature of human consciousness. So cognitive psychology studies how people think, basically. So in cognitive psychology, people study perception, some people study knowledge, some people study how they remember things, memory. Some people study people's language abilities. Some people study how people solve problems, something like that. So all these topics are covered in cognitive psychology, studies how people think. So another concept that we need to know is concept. So what is a concept? So actually, we get a lot of information from the sensory input. We form perceptions of a lot of, for all the stuff, like we can see all the stuff in the environment, we form perceptions of what they are, and we understand them, and we hear a lot of information. And also from the memory, we know a lot of information. All this information is organized and is interpreted in the brain. So the brain needs to organize this information efficiently and effectively. So how to organize all this very complex, very large amounts of information effectively and efficiently? Actually, the brain relying on one way to organize them. It is the concept. So in the brain, concepts are formed. So the brain is working on the information that is going to the mind and form different concepts. So concepts are just ways to organize information that comes to the brain or stored in the brain. So the concepts are like a lot of cabinets in the brain. So if we need to organize or store a lot of materials or documents in a room, in a building, how do we do that? In the office, how do we do that? Do we just put all the documents on the ground or on the table? It's not likely to happen. So people usually use a lot of cabinets, a lot of drawers to organize these documents, put different kinds of documents into different cabinets or drawers, right? So we need to organize those documents. So concepts are like cabinets in the brain. So the brain can organize these documents, this information more effectively, more efficiently. So we understand the world through concepts. We form a lot of concepts to know about the world, to make sense of the world. So the formal definition of concept is that they are categories of linguistic information, images, ideas, or memories. So memories such as can be life experiences. Memories can be other stuff. As we will talk about memories in another week, more detail. But they're just the concepts are just categories of all this information. Information can be about language, about visual image, can be about some abstract ideas, can be about memories. So these are just concepts. How to form the concepts? How the concepts are formed? So we usually observe a lot of the details from the visual, from the eyes, from the ears, from our skin. We have a lot of skin, a lot of senses. We observe those details, and those information come to our brain. And we combine these details into those concepts, into those cognitive structures. So examples of concepts like a car is a concept that helps us to understand small objects in the world. So there's something invented by people in the society many years ago, and we use cars to go to different places. It is a machine, right? So it's a machine. Machine itself is a concept also. So a car is a machine. So a car itself is a concept. Machine is a concept. A desk or desk itself, that is a concept. It's a something that we use. We created a desk to use it. Earth is a concept. Psychology is not the actual thing. It doesn't have a physical property, but it's an abstract concept. It's something about humans' mind and behaviors. That is psychology, right? So how do we understand what psychology is? It's a scientific study of humans' behaviors and mind. And we understand that because we use the concept of psychology to understand that. And other more abstract concepts such as justice. What is justice? It's not seeing it. We can understand what justice is. So justice is very important in laws, for lawyers or policemen, for the society. So judges in the court need to use justice, principles of justice to judge, to decide whether a person has committed a crime or not, what kind of crime it is, how severe it is. So we need to use principles of justice. So all these examples are concepts. So almost everything that we understand are concepts. We use all kinds of concepts to live our life, to understand things, to make decisions, to make a judgment, to form memories. So in the memory, there are a lot of the concepts. So we can remember what a car is, what a desk is. And another concept that is related to the concept is called a prototype. So in one concept, there are a lot of examples. For example, under the concept car, there are different kinds of cars. There are so many cars in the world. In our life, we can see a lot of cars. How do we decide what car is a car and what is not a car? Is a bicycle a car? Is a motorcycle a car? Is a truck a car? Right? So we need to decide that. We need to know the boundary of that concept. and we need to know what can ideally represents that concept. So prototype is a best example or representation of a concept. So if we talk about prototype, that is an example of a concept, and that's a best example. That means that it can represent that concept the best, the most ideal example of that concept. So that is a prototype. Probably for different people, there are different kinds of prototypes for one concept. For example, what is a prototype of a car? Probably different people have different ideas of what is the best example of a car. What can stand for car the best? For myself, I think of the best example of car is a four-door sedan. It's like a Camry or Accord or other stuff like I can't remember right now, but yeah. So those are four-door sedans, or is the best example of a car for me, for myself. So for myself, a car has two wheels, right? Has two wheels here, and let's see. Okay. Very nice. So that is the prototype of the car for me. Apparently there are four doors. Yeah, that's back door. There are windows. And here's the trunk. Here's the trunk on the back. Here's the engine in the front. Yeah, there are four doors and two doors on one side, and four wheels in total. Yes, and that is a prototype of a car for me. And yeah, so you can understand what the prototype is. And another concept that we need to know about is schemata or schema. It's a word coming from Latin or ancient Greek. What is schemata? So sometimes we know a lot of concepts. We organize information into concepts. We use concepts to understand the word to organize information so that our brain can work efficiently and effectively. But sometimes that only concepts are not really enough for us to organize all the information. So our brain also forms different schemata. It's a mental construct that consists of a lot of related concepts, a cluster or collection of concepts, and those concepts are related together. They are really close. They have a connection. So schemata is something in our mind that has a lot of related concepts. So there are different kinds of schemata in our mind. Yeah, so to work efficiently, our brain can form schemata. Like it's like something even bigger than concepts. If you think every concept is a cabinet in the office. It's like schemata is like a room in the office building. Every room has a lot of cabinets, and these cabinets are not just randomly put there, and they have relationships. Those cabinets, for example, are all about, for example, cars. They store the information, the documents about cars, and all these documents put in different cabinets in the same office room. So one cabinet is one concept, and a lot of cabinets are put in one office room, and that office room is like a one schemata. And there are different kinds of schemata, and here we can know some kind of examples like a role schema. So a role schema is about everything about a particular role in the society. So it's a collection of assumptions about how people behave, how people do things, how people behave in certain roles. Like if you're a student, how do you behave? You know that, right? So you know how to behave like a student in a school. So example can be a student role. So students go to register for classes before the semester starts. And during the semester, go to classes every week. But right now it's like, because of the COVID, and everyone goes to online class. But it's a student role. There are a lot of concepts, a lot of processes involved in this role. And the students go to classes, go to different classes, and everyone has a major and need to register for different classes to meet the requirements for graduation. And they go to every class and they listen to the lecture, listen to the instructor speaking, and do the assignments, read the textbook, and all that. So there you can see there are a lot of things that is associated with the student role. Another example can be the leader role. It's like a manager in the company. So what do they do? How do they behave? What do they say to the followers, to the subordinates? So all these are about a leader. So that is a role schema. And another example of a schema is a event schema. So it includes a set of behaviors or a series of behaviors in that event. It feels like a routine. Example can be driving on the highway. It can be an event. So driving on the highway is an event. There is a series of things that you can do to drive on the highway, or having a dinner, or you have a wedding. So it's a wedding is very typical example, a prototype of event schema. It's like a typical example of what an event is like. So there must be a lot of procedures and steps, and you need to go through that. And people need to dress like that, and bright and must dress like that. And the people who join the wedding must dress like something else. And then there need to be some steps, and there are some differences in different countries, in different places, for different people with different religious faith. But there must be some kind of formal steps in a particular wedding. Sometimes the event schema is very automatic. Sometimes it's consciously experienced, but sometimes it's very automatic, such as driving on the highway. Right? So you drive on the highway. Sometimes if you drive for many years, you even talk to other people when you are driving, because you're so skilled at driving on the highway. So everything you're doing when you're driving is so automatic. Another example is the something abstract. It's called a world view. It's somebody's assumptions about how this world or how this society should be like. So it's the world view. Some examples can be this word is really peaceful. There's a lot of peace in this world. People are friendly to each other, and there are a lot of wars in the world. That is one word for one person. That it includes a lot of beliefs, ideas, and assumptions about how this world as a whole or the society as a whole is like or should be like. And another example is a self schema. It's a schema about everyone's self. Is a set of beliefs about the self. So every aspect of self can be included in the self schema, or sometimes self schema is called self concept. So in psychology, we are more likely to use the word self concept to mean self schema. So it's a very stable set of beliefs about self. So people form very, very stable beliefs about themselves. So once they form the self schema, it's not likely to change a lot. It's very stable and it lasts a very long time. It lasts for the entire life because people have knowledge. People know about themselves. They know their like identities. They know their different features like age, birth year, gender, height, or skin color, name, and other abstract aspects such as personalities, what kind of person they are. So everybody has some kind of knowledge about their own personality or their social relationships with others, their wives, their husbands, their girlfriends, boyfriends, their father, mother, and all that. So all this information about the self is clustered, organized into the self schema. So right now we have talked about what the concept is and what a schemata is. So we have a basic understanding of how the brain is consciously working to organize all this information that comes to the mind. And the next topic, let's talk about language. It's another topic. So language, you know that everyone knows how to talk about language. So everyone knows how to speak a language, at least one language. And almost everyone can understand other people's talking. And also language includes writing language, like reading and writing. So we can understand different words that is written down on a paper or on a screen. We can write them, we can read them, and either oral or written language. So we can use language to communicate with other people. So why do we use language? For sure, we need to communicate, we need to interact, we need to exchange information with other people so that we use language. For example, if there is only one person in this world, only yourself in this world existing, you don't have to use language anymore. You don't have to write or to talk to other people because no one is communicating with you. So why language? Why we use language? Because we need to communicate with other people. And yeah, in this background picture, you can see different way of saying hello in different languages. Like hey here, and this is French, I guess. It's ciao, and it's a salam. Salam is Arabic. Here's hello. It's like another European language that is very close to English, I guess, because it's not HE, it's HA. It's very close to the English version of hello. Yeah, here's also ciao. It's probably French, and I don't know what this is, but there are different versions of saying hello. Yeah, people use different languages to communicate. So there's a formal definition of language. So language is a communication system. So first, it's a system for communication. That system has need to use words and systematic rules to organize words into organize the words to transmit information from one individual to another. So it's a system that people transmit information to each other. So one person gives information to another person gives information to that person. They exchange information. But in a language, they use words, and also they organize the words into a very organized way, use some kind of a rules, abstract and systematic rules. And there can be talking, writing, sign language. Okay, sign language is also a language. So it's used by the people who cannot talk or hear, right? So use different hand gestures to communicate with other people. And also it is interesting to know that for sign languages, there's not only one sign language. So in sign language, they also have different languages in different countries. So if you see different people who use sign languages from different countries, they might not communicate because they use different sign languages. It's like just like our language that we speak every day. People from different countries, they might not understand each other because they use different languages. So in the language, there are two very important things. The first one is all the words. It's called a lexicon or the vocabulary. So vocabulary means all the words. It's also called lexicon. And the second thing that is very important there, that is grammar. So grammar is a set of rules, abstract rules that organize all these words into something that we can understand. They are used to convey the meaning through using lexicon. So grammar organizes all the lexicon together in a way that people can understand each other. So why people from different countries cannot understand each other, even though they all speak a language, because they use different lexicons and different grammars. So that's why they cannot communicate very well, because they do not share the same lexicon or the grammar. But people from one country usually share the same lexicon or grammar, like English words, English grammar, so that we can understand each other. If I use some words that you never heard of, you wouldn't understand me. And another case is like if I use all the words that you hear of, you know of, English words, but I use a very strange grammar that you never know of, you might not understand me. So we need to use the same lexicon and grammar to understand each other. So a language has at least two very important parts: all the words and the set of rules, that is grammar. So that is basic information about language. And another topic that we can talk about is how language is developing. So how do humans gradually learn to speak language? Because since everyone was born they cannot understand language. So language is not instinct. It's not something that we are able to do at the beginning of our life. We need to learn to speak a certain language. So how the language is developing. So first of all, language is compared to other abilities or skills. Language is very difficult thing to do. It's very difficult to learn because language itself is generally very complex compared to other skills like walking or running. So walking, running are very, very simple for humans, but even for humans, language is very difficult to learn. But the young children can learn any languages, those infants or newborns before 5 years old, they learn any languages very easily and very quickly. They never have any trouble to learn language. And they can learn a few languages at the same time. And that is magical. For adults, for people who are 18 years old or older, they have a lot of difficulties. They spend a lot of time to learn a foreign language or another language. Usually people don't learn a lot of languages when they are adults. But for young children, they have no problem at all to learn language. They don't even put effort in it. They don't really consciously put their effort in learning a certain language. They don't allocate a period of time to learn a language. So if we adults need to learn another language, we need to sit down in front of the desk and take our notebook, read a textbook to learn language. We need to allocate like 1 hour every day, for example, to just learn language. But children are not like that. They just play every day and they can speak the language. That is very magical. So for them, it's very easy. And young children can learn a few languages at the same time. Is, for example, the people from Switzerland, the Swiss people, they grew up learning or being able to speaking at least 3 languages. So a lot of people are just they just grew up speaking a lot of language at the beginning because in their families, their parents, their grandparents speak at least 3 languages: German, French, English, or Italian. So that depends on different families. But at least they speak at least 2 languages. A lot of people are able to speak 4 or 5 languages in Switzerland. It's not a problem for them at all because they just learn at the beginning of their life. They just learn to speak that many languages. And so that people are born with a predisposition to learning a language, to master a language. Because it's so easy for the young children to learn any languages, so that psychologists or scientists guess that people are born with the tendency to master language very easily. And compared to language abilities, like doing math, calculation, doing math questions, it seems not like a predisposition for humans. Humans are not really good at calculation or think about mathematical questions or like calculating probabilities. People are not likely to have the predisposition to master that ability. But humans are, it's very easy for humans to learn a language. Also, there seems to be a critical period for learning a language or mastering a language. So what is a critical period for learning language? Any children can master at least one language before their age 5. So in the first 5 years of everybody's life, everybody can learn or even master a language, at least one language. Some children learn like master 3 or 4 languages, like we just talked about. So that is a critical period for acquiring or mastering a language. The period is from the age 0 to age 5. So that is a critical period for learning a language or mastering a language. And after that, after age 5, it is more difficult for people to master a language because that critical period has passed. And once the critical period for somebody has passed, it is very difficult for somebody to learn a new language. But if in the critical period, that person has no difficulty to learn a new language. But that critical period only lasts for about 5 years, from birth to age 5. And in that critical period, the way to master a language is very different from learning a language for adults, for the people who are outside of the critical period. For example, for the young children, you cannot see them to really intentionally learn a language, learn how to say something. They just come very naturally. And also their language abilities seem to grow explosively. I would use the word explosively. It's like an explosion of language abilities. So for example, before age 1, children only babble. Babbling means that they only produce some single syllables repeatedly. So what is a syllable? It's like it's very simple combination of voice or sounds, like ma, like a da, ba. So those are the single syllables. So say examples of syllables. Like ma, da, ba, ga. Like this. So these are the single syllables. They just produce this very easy single syllables repeatedly. So like ma, 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 da, 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 da. They say one syllable many times. That is what is happening before the child is before age 1, before 12-month old. And suddenly there's one day they start to say single words like mom, dad, car, something like that, or eat, banana, something like that. So they suddenly be able to, say one words, say some single words like that. And it's not just single syllables, but they start to say something that is meaningful. It happens so quick, and people are not even realize that. People, when their parents hear their babies are saying something that is meaningful, they are shocked. They are so amazed. and they are so happy because it just happens so suddenly. It's not like a really gradual process. It's not like suddenly there's one day that this baby starts to say some single words, not only just the babbling. And before age 2 and after age 1, there is a new stage. There's one day that this baby starts to say 2 words at the same time. So before they just say some single word at one time, say single word one time, say another single word another time. And suddenly, this baby say 2 words together. So it's like a I banana. So if some baby say I banana, what does it mean? It probably means I want to eat banana, or I want to play with this banana. Something like that. So it's like it's called a 2-word stage. In the 2-word stage, the baby only produces 2 words together at one time, but it's a huge improvement than just saying 1 word at one time. So from 1-word stage to the 2-word stage, it suddenly happens. And their parents are shocked, they're amazed, and they're so happy. Oh, our babies can say 2 words at the same time. It means that the baby starts to have the ability to produce a sentence. So if the baby just say 1 word at a time, it means that it doesn't have they don't have the abilities to produce the complete sentences. But in the 2-word stage, it is a sign that they are able to produce a complete sentence. So their thinking ability is more complex, much more complex than a 1-word stage. So it's very, very, very interesting that their ability to the development of language in the critical period is very different from the language development outside of the critical period. It's like a climb onto a stairs, step on the first. Yeah, so it's like it's not like a car is running. But it's like there's one stage, and suddenly there's another stage, and suddenly there's a third stage, something like that. And another topic about language is that the relationship, how the relationship between language and thought. Yes. So some people, there is a very long debate and a very famous debate in psychology about the relationship between language and thought. So some psychologists believe that language shapes thoughts. So there is language first, then people start to have thoughts because they need to think, they need to speak language. And some psychologists believe that thoughts happen first, and those thoughts can shape language. So people start to think, and then they can speak language. So which produces which shape which? Does language shape thoughts, or thoughts shape language? Which one is right? So I think that both ways are existing. So language can shape thoughts, and also thoughts can shape language. For sure, thoughts can shape language because before talking about something, we need to have idea, right? So we need to have idea of what we want to say. We need to think first, and then we can talk. We think and we talk. We think and we write. So that's how thoughts can shape language. But language can heavily influence how we think as well. There is some evidence that shows language can also shape thoughts. So there's one example. The English speakers, the speakers whose first language is English, they have a tendency to talk about time changes along a horizontal dimension. So the time is changing, right? So time is passing. But how to talk about time changes? English speakers usually talk about time changes is in a way that the time is seems like the time is on a horizontal dimension. So it's like there is axis of time. Time is passing, right? So time is going this way, going to the right. And here's a little person who is on the axis of time. And that person is going forward on the axis of time. So it's more like a horizontal dimension. So there's one phrase like a running behind the schedule. It's like a schedule is here. That is a schedule. And this person is running behind the schedule. So it's on the horizontal dimension. However, in Chinese speakers, the speakers whose first language is Chinese, they tend to talk about time changes along both a horizontal and a vertical dimension. So they can talk about time changes along a horizontal dimension, just like a running behind a schedule. There's no problem like talking about that time changes like that. But also they have also the expression of describing time changes in a vertical dimension. They also talk about the time is like going from up to downside. So they also have that feeling, or they have that concept. The time is like on a vertical dimension, and time is coming from the up and going to the downside. So because they sometimes describe the past as up and describe the future as down. So past is where is up, and future is where is future is down, downside. Of course, we can talk about future is in the front, past is behind the back is in the back. But also talk about the future is the downside and the history is upside. And there's a experiment. They recruited the participants from different who speak different languages. So some of the participants speak Chinese, and some of the speakers speak English. And in the test, there's a step before the experimental stage. So they are primed to think vertically. So it basically means that they are doing something in the experiment. They are doing a task, and that task lets them to think about everything vertically. So that's called they are primed to think vertically. So through that task, they are thinking about everything vertically. And in that situation, they are asked to think about the time changes, about time. Yeah, they found that the Chinese participants, the participants who speak Chinese, they were faster at processing the information about the relationships regarding the time. So they are processing the information about time changes faster. Why is that? Because in the daily time, they are thinking about time changes also in a vertical dimension. Because they are primed to think vertical. They think about everything vertically in that moment, and they are asked to think about time changes. They are thinking faster. It means that they get used to think about time changes using the vertical dimension. And that is a comparison between Chinese participants and English participants. English participants are slower to process time changes in a vertical dimension because they are not used to do it. They do not get used. They do not really think about time changes in a vertical dimension. So that's why they are slower. They are doing something that they are not used to. And there's another evidence that showing language can influence or shape thoughts. There is a tribe or ethnicity. It's called the Dani people. Dani people is a ethnicity in the country Papua New Guinea. It's an island in the Pacific Ocean. So Dani people in Papua New Guinea, they have only two words to describe color. One word is for light and the other word is for dark. So they only have the concepts of light and dark. So they don't have other words for color. As a result, they have a difficulty to conceptualizing other colors. They cannot form the concepts about color. So we know that concepts are used to organize the information. They get the information. They see all the green color, all the blue color, all the, that the sky is blue, the water is sometimes blue, sometimes green, and the plants are green. They get those senses, but they cannot form the concepts of those color. They don't understand what is red, what is green, what is blue, what is white, what is black. They only have the concepts about light and dark. So that is the evidence that if without the proper words, we don't even have the proper concepts. We cannot even form the concepts that are described by words. They can tell the differences between different colors. If they show different colors to them, they can know, oh, these are different colors. However, they cannot name them. They cannot say, oh, this is red, this is green. They cannot do that because they don't have the words to describe those colors. Even though they are able to tell the differences between different colors. It means that they get the senses, they get the information in their brain, but they don't form the concepts about those colors because they don't have words for them. So there is another evidence that showing language can also shape thoughts. And that's all about language for today. And next we can talk about another topic in cognitive psychology, that is problem solving. So we need to solve different kinds of problems in our real life. So how to solve problem? There are different strategies. So what is a strategy? So a problem-solving strategy is a plan that can be used to find a solution. So we can form a plan of how to behave, how to act to get a solution. We need to, the final goal is to get a solution, right? So how to get that solution? We have a plan of action. So that plan of action is a problem-solving strategy. So we have a strategy. It means that we have a plan of action that tells us how to find that solution. There are different kinds of strategy. So the first strategy is called trial and error. Trial means try, error means mistake or error. The process is like, it's very simple. We all know that. How to find a solution? We don't know. We just try one solution. And we see if it succeeds or it works or not. If that solution works, that's okay. That's the end of the strategy. It works. If that solution does not work, we can use another way, right? So we can use a different solution. We try another way. And if yes, that's good. And if not, again, we can try even another way. If not, we can try another way. If not, we can try another way. We just try and see if it works. If not, if it is not working, try another way. So we can repeat the 3 steps for many, many times until it works finally. It's very simple. Try it, see if it works or not. If there is an error message, it means that it's not working. Try another way. Try error message, try error message, try error message until it works, until there is no error message. So it's called a trial and error. It seems like looks like sounds like it's really like a not very smart way to find a solution, because you might try a lot of times. However, it works a lot. It works very well. You can try every possibility. You can try every possibility, and you can finally find the right solution. That's the power of trial and error. And another strategy is called algorithm. So algorithm, that word is usually heard in computer science, right? So in computer science, the coders, the engineers need to develop all kinds of algorithms to write codes, so that the program can write the program with proper algorithms, so the program can working well. There are different kinds of algorithms. Actually, those algorithms are the way to find a solution, right? So they need to write a program, and then that program has a certain function, realizes certain purposes. Actually, the algorithm help them to find the right solution. So algorithm includes the step-by-step instructions about how to achieve a desired outcome, about how to get the certain goal, how to realize a certain function. So in algorithm, there are step-by-step instructions. So it's like when you buy a new machine, or you download a new app to your smartphone, you do not really know how to use it, right? So you buy a new TV, for example, and here's an instruction book for you every time you buy a new TV, right? So you buy any new electrical device, there is an instruction book for you, instructions, menus. And in the instruction, here are step-by-step guides for you to do a lot of things. Right? So how to install this TV properly, how to turn on this TV, how to turn off this TV, how to use the remote controller of that TV. So all these things, all these problems, they have the instructions that tells you step by step how to do it, how to realize, how to manipulate. So that is algorithm. And another way is using the heuristic. Heuristic is not like a trial and error. It's not like an algorithm. There's no step-by-step instruction. There's no the process of trying different possibilities. Heuristics are just mental shortcuts. And we meet this problem, and suddenly we have a feeling. Suddenly there is some kind of idea that comes to our mind, that occurs in our mind. That is a heuristic. We suddenly think, oh, we can really rely on that thing to get a solution. That is very quick, but for a lot of times, it's wrong. A lot of times heuristics are wrong. It does not guarantee to find the right solution. It does not guarantee to solve the problem because they are just mental shortcuts. It doesn't guarantee, it's not logical, it's not rigorous. So algorithms are very rigorous. Trial and error are also very rigorous, although it's very simple. But heuristic is very simple, but it's not rigorous. It doesn't guarantee you can solve the problem. Oftentimes it's wrong. So example is a small test for you to do at the beginning of this lecture. We can go back to that test. So if you think that you can just directly go Upper East Side to the Upper West Side and go through the Central Park directly, you are relying on a heuristic. You just use the straight line to connect these two parts. It's actually a heuristic. Doesn't guarantee you find the right solution. So it's like a shortcut. This straight line is a physical shortcut, but heuristic is like a mental shortcut. And yeah, we use this like metaphor, but actually this is also a mental shortcut because you do not really think about it carefully, right? So you just think, oh, there are two places. You just use a direct line to connect these two places. That's good. And this also is an example of a heuristic. And the first series looks more like a random series, but the second one doesn't really look like a random series. It's just from intuition, from feeling, from gut feeling. It comes to your mind so quickly and without really think about it. So when you use that way to think about this question, you are using a heuristic. That heuristic is called a representation. It means like if something looks like something looks a certain thing looks like the solution, and you think that's the solution. So that heuristic is called a representation, because the first series is more representative, or it's more like a representation of a random series. However, if you use the algorithm to solve this problem, you use the mathematical formula to really calculate the real probability. You can get a number of which one is more likely. You will find that they are equally likely. So if you use a formula like a 0.5 times 0.5 times 0.5, you times the 0.5 for 8 times, it's the 0.5 to the 8th power. That is a algorithm. There is a step-by-step, very rigorous step instruction of solving that problem. So these are the basic three strategies to solve a problem. And they are frequently used. So everyone is frequently used in our daily life. You are not even aware of it. Okay, that is about problem solving. And this part is not that there's not a lot of stuff in this part. And next part, also the last part in our lecture, is about intelligence. So we have talked about cognition. We have talked about thinking. We have talked about the brain uses concepts to organize information. But how does everyone's mind is working? How do we know that? How smart people are? So we can use intelligence to know about everyone's smartness. There are different ways to categorize different kinds of intelligence because people find that, scientists find that, how do we know that somebody's intelligence is? Intelligence, people are intelligent in different aspects, right? So there are different aspects of life. They can be smart in this aspect, but not smart in that aspect. And other people may be smart in that aspect, but not in this aspect. So people are maybe different smartness in different fields, in different aspects. So there are different ways to classify intelligence. And there's one way to classify intelligence. It categorizes intelligence in two categories, in two ways. The first kind of intelligence is called the crystallized intelligence. And that is the knowledge that the person has learned, the ability that person has learned, and and also the ability to retrieve the knowledge, because the knowledge is stored in the memory, in the brain. Every time, every moment that person needs to use this knowledge, the person is able to get it, is able to retrieve it from the memory. So crystallized intelligence includes the acquired knowledge and also the ability to get those knowledge from the memory quickly. So this is a crystallized intelligence. Why it's called crystallized? Because it's fixed. Those knowledge are fixed in their mind, in people's mind. So they're not flexible. They're not like the flowing or moving. They're just knowledge in their mind. For example, how many countries in the world are there in the world? How many states in the United States? What are the names of all those 50 states, like California, Oregon, Nevada, Arizona, New Mexico, Texas, New York City, New York State, Florida, and so forth. So those are just the fixed knowledge. That is a representation of crystallized intelligence. And another type of intelligence is called the fluid intelligence. It's flowing, it's moving, it's really flexible. So it's called fluid. It's not like stones or smaller crystallized stuff. It's moving. Its ability to solve problems. We have the ability to solve problems. We have the ability to figure out really complex relationships in that problem. We need to have an ability to solve that problem. So that is fluid intelligence. Fluid intelligence stands for our ability to see the complex relationships among different things and the ability to solve problems. So if we have high fluid intelligence, we have a very strong ability to solve difficult problems. If we have a low level of fluid intelligence, we do not have the very strong ability to solve difficulties with the same difficulty level. So the crystallized intelligence and fluid intelligence are different. So, for example, if I know all the names of all the states in the United States, doesn't mean that I can solve a problem in real life. Right? So some problems in real life are really complex. With the really high fluid intelligence, doesn't mean that that person has really high crystallized intelligence. For example, a person may be very smart, solve a lot of practical problems, but that person doesn't know the names of all the 50 states in the United States. Doesn't have a lot of knowledge. So this is a way to classify intelligence. And there is another way. The second way to classify intelligence is developed by the theory about intelligence. It's called a triarchic theory of intelligence. So tria means three, right? So triarchic theory of intelligence. It implies that in this theory, the intelligence is divided into three kinds, is classified into three kinds. First kind is analytical. And that's the brain's ability to be analytical, to analyze, to evaluate, to judge, to compare different things, contrast different things. So analyze with logic, analyze the information with the details of those information, evaluate how everything is performing. So that kind of ability is categorized as the analytical intelligence. Another category of intelligence is called creative intelligence. So it's not about analyzing, it's not about comparing, but it's the ability to be a creative, to invent a new solution to solve a problem, to imagine a new solution to a certain problem or situation. It is the ability to be creative, to get new stuff, to imagine new stuff, to invent, to create something that has never happened before. That is creative intelligence. Another intelligence is practical. Practical means that that's the ability to get the solutions, find the solutions that work well in daily life. So sometimes we know a lot of stuff. We can evaluate, we can analyze, we can solve the mathematical questions very well. We can know the difference between psychology and, for example, psychology and sociology. We can compare and contrast psychology and sociology. That is analytical, but we do not know how to, like, for example, calm people down. if somebody is very angry and we need to talk to that person and let the person do something, how do we do that? We do not know. Sometimes we do not know. And that is different from analytical intelligence. We need to have some kind of a daily life experiences, some kind of a street smarts to solve that problem. We have met a lot of practical problems in real life so that we can be very smart in terms of practical intelligence. So practical intelligence, it means the ability to find the real solutions that work well in the real day life. In real life. So this way to classify intelligence is explained by the triadic theory of intelligence. And there is another way, a third way. It is developed by the psychologist Howard Gardner. Howard Gardner is called the multiple intelligence theory. It's another theory about intelligence. And this theory tells us that there are 8 kinds of intelligences in life. There are 8 types of intelligence in different aspects. So that's why it's called a multiple intelligence theory. So what are the 8 types? Here's a table that shows all these types of intelligences. So the first one is verbal linguistic. Means that the ability to read, to write, to memorize words. So it is about talking. It's about the language. So ability to produce language, to understand language. And on the third column, there's also something about learning style. So that means that in this multiple intelligence theory, it also says that people who are high in different kinds of intelligence, they are more used to a learning style that is more consistent with that intelligence. For example, if somebody is really high in verbal linguistic intelligence, somebody is really good at reading, writing, and memorizing words, the best learning style for that person is to learn by speaking and hearing. So that is a very good learning style for that person because they are really good at this. They're very, very strong at verbal linguistic. So the best way for them to learn new stuff is to use that ability to learn, to hear, to speak. So that's what the third column means. So first one, verbal linguistic. They're best to learn by hearing and speaking. And the second one, musical rhythmic. It means that they are really good at hearing sounds. They're really good at hearing or being sensitive to rhythms, to tones, to music. So they are really good at music. They are really sensitive to any sounds that is music, melody, rhythms, tones. So this kind of people are better to learn through melody and music. And the third kind of intelligence is logical mathematical. And yeah, you can guess that this kind of ability is to use the logic, to reason, to working on numbers, working on mathematics. And the people who are high in logical mathematical intelligence, they are really good at critical thinking because they use logic a lot. They are really rigorous. So the best way to learn for this kind of people is to learn by using logic, right? So using basic logical principles, abstract thinking, to learn. And next type is visual spatial. They are really good at seeing. They are really good at judging some kind of a space information. Information about the space, the physical space. So this kind of people, they are good at, they are better to learn by seeing, observing things, and observing the patterns. And another one is called bodily kinesthetic. Bodily kinesthetic. This kind of intelligence is used to controlling the bodies, controlling the physical bodies. So a lot of athletics, about a lot of sports players, they are really good at, they have really high bodily kinesthetic intelligence. For this kind of people, it's better to learn by doing. They need to move, they need to do things to learn. They cannot just sit down there and be quiet and learn and talk. They need to learn by moving, by doing. There is an interesting story. There is a very great dancer whose last name is Jordan. I forget the first name. She was a very famous dancer in the American history. She was the person who were born in 19th century and grew up in 20th century. So she was a dancer, very, very famous dancer in the earliest 20th century. So when she was young, she was diagnosed with the ADHD. So ADHD stands for the attention deficit hyperactivity disorder. So you know that some children got that disorder, and means that they have the very weak ability to pay attention. They have too many activities. They cannot get focused. So Jordan was diagnosed with that kind of ADHD disorder, and she was not allowed to go to school anymore because her teacher told her parents that your child cannot get focused, cannot sit down, and have too much activities in the classroom, and other children are influenced by her. And of course, her parents were very sad, but they found that Jordan was very good at dancing, really good at moving her body. So they sent her to the dancing school. And it turned out that she was so good at dancing. It's like the dancing school is the right place for her to stay. And her performance and her achievements, her scores, her school performance was really nice in the dancing school. And later, when she grew up, and she became very, very famous dancer in the history of the United States. So I guess that she had really high bodily kinesthetic intelligence, but very low verbal linguistic intelligence, because she just doesn't sit down. You know, she was not quiet. She just moved all the time. So she needs to learn by doing. So she becomes a dancer. And next one, intrapersonal intelligence. So this kind of intelligence is used to understanding the self. So very good at have the intrapersonal insights. To very good at have kind of a like a self have a so really good at understanding what is going on inside of themselves. So this kind of people are better to learn by engaging in independent study projects. because they are really good at understanding themselves. The other one is very interesting. It's like these two are in contrast, interpersonal. So they're really good at communicating or like interacting with other people, sensitive to others, good at the cooperation, and really good at understanding others. So this kind of people, they can learn by participating in a group or be in a environment that a lot of people are around. So in that kind of environment, that is the best learning style for this kind of people who are high in interpersonal intelligence. And another one is naturalist intelligence. It is used to observing and understanding the nature. It is about nature, really sensitive to the information about nature. So they good at learn things about nature. And the next one is emotional intelligence. So they have a really strong ability to understand emotions, to understand their own emotions, to understand other people's emotions. And also they are good at manage themselves emotions and also influence other people's emotions. They can calm other people down. They can please others so that other people can be happy. So, and also they can let themselves be happy and calm themselves down. So they are really good at stuff about people's emotions. They can learn by they can learn stuff about people's emotions, like interpersonal relationships, stuff like that. They're interested in the interdependence of people. So these are the 8 intelligences. I think this theory makes sense because we are good at different things, right? So different people are good at different things. We can, from our daily life, we can apparently tell that some people are really good at sports or dancing. They are high in bodily kinesthetic intelligence. And some people are really good at verbal linguistics. They are good writers. They can understand a lot of the things. And some people are just musicians, right? So they are really high in musical rhythmic. And some people are really good at mathematics. I know a person who is really good at natural science and math. So he's a person who is really high in logical mathematics. However, he was not good at language at all, not good at writing or speaking. That is very difficult for him to learn a language. Yes. So he might be really low in verbal linguistics. And I also know that some people are really good at sports, but they are really bad at doing math or learning something else. So different people have different intelligences, have different advantages or disadvantages. And yeah, so there are 8 types of intelligences according to the theory of multiple intelligence theory. And also it involves, it produces or like elicits a lot of a discussion about the best way of education. So the example that I just talked about, the Jordan, the very famous dancer, she was a very typical example of what kind of education is the best education. I think no education, none of the ways of the education is the best. It's only the best for some students, for some children, because children have different intelligences. They are good at different things. They need to have different learning styles. Some people need to learn by doing. Some people need to learn by sitting down and hearing and speaking. some people need to learn in the social environment. Some people need to learn independently. They're different. They're used to different learning styles. But however, usually the way of educating people, students, is that you come to the class, you sit there, especially the college education. You sit there and you do nothing. You hear the lecturer talking. Lecturer is talking a lot, and all the students are just sitting there and hearing. Very passive. Very passive. If a person who is very good at moving or sports, they need to learn by doing. They cannot get used to this kind of learning style, right? So actually, the college education or other kinds of education is good for the people who are high in verbal linguistic intelligence. So first kind of people, learning by hearing and speaking. The way of education today is actually good for this kind of people. Not really good for people who need to hear music, need to observe, need to doing things, right? So not good at, not friendly to those kind of people. So, and also it has the implication that everyone needs to find their own way of learning and also find their own way to live their life, to improve their own life. So people have different gifts. They have different intelligences. They're good at different things. Everyone has a responsibility to know him or herself, to find the best way to live their life. So that's one implication from this theory. Another related concept about that is related to intelligence is creativity. So creativity is the ability to get new ideas, to create new ideas, discover new stuff, to generate new ideas, to get new solutions, to try different new possibilities, to think of new possibilities, new ways. So that is a creativity, to get something new, to create something new. So when people are creative, they often engage in kind of a kind of thinking, which is called divergent thinking. So when they are involved in divergent thinking, they are more likely to be creative. So divergent thinking means that thinking outside of the box. Think of something that is new, that is unique. Try get a lot of different possibilities. Try different possibilities as possible. So when people are thinking divergently, we can think of some kind of unique solutions, and they can think of different kinds of solutions to a same problem. So that's why they are really creative. There's one problem, but they can have different ways to solve that problem. And the convergent thinking is the opposite way of thinking. So convergent thinking just means that we need to get one correct answer to one problem. To that problem, there's just one standardized answer. We need to get that answer to think of that correct answer to that problem. That is convergent thinking. So when we take the test for every multiple choice question, we need to involve in convergent thinking, right? Because there's only one right answer. We cannot just answer all of this answer can be right, that answer can be all right also. It's not possible. We need to get one correct answer. That involves convergent thinking. But divergent thinking is about thinking about a lot of solutions to a same problem, and those solutions are new or unique. So that is creativity. And right now, creativity is more and more useful and important in the nowadays workplace, because in nowadays, it's not just producing the same product again. It's not like factory work. It's more like, because factory work can be realized by robots, by machine. So humans are more likely to engage in some work that needs creativity. For example, marketing. How do you sell your products to the customers? How do you let the customer know your product is good, is unique? You need to try out different ways. You try different solutions to market your product. And also, nowadays, there are a lot of industries about ideas about designing, right? So you need to design a lot of interesting products so that customers can buy those designs, actually. And the next related concept is IQ. So IQ stands for intelligence quotient. So I and Q. IQ is intelligence quotient. It's a number. It's a score in a test. Somebody take a test and get a number. That is the IQ. The score is designed to measure intelligence. So IQ tells that person's intelligence. A certain number, that IQ can let people know the level of a person's intelligence. And the very popular intelligence tests, there are a lot of intelligence tests in the world right now, but the most popular one is called the Wechsler Adult Intelligence Scale, or it's called WISE, W-A-I-S, Wechsler Adult Intelligence Skills. Of course, there's a children version, so it's probably called Wechsler Children Intelligence Skill or something like that. But for adults, we can use Wechsler Adult Intelligence Skill to measure our own intelligence. And yeah, everyone can take that test, and a lot of people have taken the same intelligence test. And scientists found that the IQ scores in the population. So a lot of people take the test. There are different kinds of people, men, male, different ages, and people with different education backgrounds, different life experiences. They all take the IQ scores and the intelligence test. They get the certain IQ score, and they put all the IQ scores together on a stuff like this, and it found that the distribution of IQ scores in the population is like a bell curve. It's curved like this, and on the y-axis, this is the frequency, and this is the IQ score. It means that the higher the line is, the more frequent this number is. That means that this table shows that, this picture shows that there is the most people who get the IQ of 100, because the line here on 100 is the highest compared to other places. So the most people get the number of people who get the IQ of 100 is the most. Yeah, that's the right way to describe it. you can see that there are not a lot of people who get the IQ of 60 or 70. Not a lot of people to get the very high IQ like 130 or 140. Most people get the IQ of between 80 and 111, or 90 and 111, or something like that. So the like 15 below or above 100, something like that. So that is a distribution of all the IQ scores. It's like a bell curve. So bell is like this shape, right? So this is like bell. No, it's not like this. So bell curve is like this. The bell is like this. So the bell curve is like this. So this is called a normal distribution of something. So normal distribution, means that that's the distribution that normally occur. So for a lot of things, the distribution is like this. For example, the people's heights in the population is also like this. Most people are that high, and there's very few people are very, very high, and very few people are extremely low. And most people are about the same height. Yeah. Some people are higher, but some people are lower, but not many people are so extreme. Most people are like around the average height. The IQ is like this. Most people's IQs are around the average IQ of 100 in this table. So for they have the average IQ scores for every country. So you can find the data online. Let's find the data online. I found a website that shows the data of all the average IQs by country. So you can see a world map here. You can see the list of rankings. So the first country, the country that ranks the first is Singapore, 108. Yeah, so it means that on average, the Singaporean people are the smartest in the world. The average is above 100. It means that most people are above 100. So because the average is 108. And the United States is ranked 26 here. The average IQ is 98. Yeah, it's like 10 below the first one. It's also okay. It's like around 100. It's the same with France. Yeah, there are a lot of other countries. So it's like you can see, you can find the average IQ scores for each country. For all the countries, the distribution of IQ are all the bell curves for every country. So that is the IQ, and that's the distribution of IQ. And the next question about intelligence is why we are intelligent? Why people are smart? Where is the intelligence from? How do they develop their intelligence since they were born? So some evidence shows that the IQ is very heavily influenced by their own genetic makeups. It means that how smart they are is decided by their own DNA, by their genetics. They're born to be smart or not smart. There's a finding that the relationship of IQ between two identical twins is about 0.7. So you know what twins are, right? So if they're born at the same time, they're the twins. Identical twins means that they have the same genes. They have exactly the same genetic makeups. And these are identical twins. Because some twins, they are not identical. They have different kinds of, they have a different set of genes, but identical twins have exactly the same genes. Like it's a copy of two, it's like two copies of one person. And their IQs have some kind of relationship because they have the same genes, right? So the relationship is 0.7 if 1 stands for total overlapping, 0 stands for no overlapping. So if if the number is 1, it means that for every identical twin, the two people's IQ is exactly the same for everything, but the number is not 1, it's 0.7. How to explain that number? It means that for most part, or if you find a reason for why their intelligence is like that, for 70% of the reason comes from the genetic makeup. So that's how we understand this number. So the relationship, the strength of the relationship of the IQs between the two identical twins is 0.7. Yeah. So it means that basically for any two identical twins, their IQs are very similar. It's not really likely that one is very smart, one is very not smart. They're either both very smart or both very not smart. So it's like it's a fact. So the IQ is sometimes the IQ is there's a range of IQ for every person that every person can get. So for example, sometimes for some people, their genetic makeup decide their IQ can be 100. But in reality, their IQ can be 101, 102, 105, or 95. There's some, they cannot be really smart. They cannot be 130. They don't have that kind of a genetic makeup. That is how we understand IQ is heavily influenced by genetics. But however, IQ is also influenced by other factors, such as the environment that person grows up. So the genetic makeups, the genes can decide what kind of range the person's IQ is in when the person grows up. But when the person grows up, the IQ is influenced. And IQ can be higher, can be lower. For example, this person's genetic makeup decide this person's IQ is 100. But when the person grows up, the environment is very good for the person to develop his IQ. So finally, his IQ goes to 105 or 110. That's also possible. So environment in which the person grows up also influence the IQ of that person. For example, in an environment that is very stimulating, it means that that environment, there are a lot of elements that can stimulate the child. The child sees a lot of interesting things, hears a lot of interesting sounds, something like that. In that kind of environment, the child is more likely to reach the full potential of intelligence. That means that the children can get as high intelligence as possible, which is constrained by their own genetic makeup, but can reach the full potential because the genetic makeups can only decide a range of final intelligence. And what number is it, what intelligence is it, can be influenced by the environment. If the environment is very stimulating, is very rich, there are a lot of toys, there are a lot of people are around this child, the child gets a lot of stimulation. The brain can developing very well so that the child has a very high intelligence. And what environment is considered as stimulating? Besides the stuff about like toys, colorful room for that child, or a lot of people are hanging around. What else is important to be a very stimulating environment? I guess there need to be enough safety, shelter, and food. So the nutrition, the safety must be enough, so that the child's physical body can develop. And I heard that the fish is very useful for children's brain to grow. So if you have children, you can ask your children to eat more fish. Fish is very healthy for brain development. And also, I guess, social environments where there is a lot of love and trust. In this kind of environment, there may be a lot of it may be that maybe the case that the child is growing with high intelligence, because love and trust is very important for the child to feel safe. So in that kind of environment, the children can feel safe and feel safe to play, to explore the environment, to think about stuff. If they are scared all the time, they cannot spend their time to think about the things. Another example can be the social environment where parents can talk a lot to the child. So do you remember the book, 30 Million Words? So I recommended this book at the first week of the class. So in this book, it has a very stunning conclusion that if parents talk to their child before age 3 for talk like more than 30 million words to their child before the child is age 3, the child can be very, very smart when the child grows up. So that's very interesting conclusion from the book, 30 Million Words. So I think in the social environment, what is the stimulating social environment? Maybe toys or things are not that important, but parents accompanying, companion is very important. Parents talking is very important. Parents need to talk a lot to their child so that child can grow their intelligence very well. And what else can be there? What else can decide this environment is stimulating or not? So you can think about it. There may be a lot of other factors. So this is all the stuff for this week. So we have talked about cognition, we have talked about concept, schemata, we have talked about some topics about language, about problem solving, about intelligence. So these are the concepts that you need to know of for this week, like a cognition, concept, schemata, language, critical period, algorithm, heuristic, and a crystallized intelligence, fluid intelligence, and also you didn't know amount of intelligences in the multiple intelligence theory. So you are better to know about every intelligence in that theory, but you are not really required to directly recall like what kind of intelligences are there. But you didn't know the basic concept of multiple intelligence theory. And the last concept you need to know is creativity. Yeah, so these are all the stuff that you need to know for this week. And thank you very much to watch this video, and see you next week. And don't forget to take the quiz for this week, and you can start learning next week. Next week is about memory. And let's see next week.